Hi, welcome to everyone's favourite segment, Mailbag. It's been a while, but we've got a bit of a backlog. Won't be able to get through it all today, but this is a segment where anyone, including companies, can send in stuff randomly into the mailbag and we take a quick look at it. And if it's interesting enough, might even get its own video later. So let's check it out. This one, unfortunately, I already opened it because they didn't put Mailbag on it. If you're going to send something in, Mailbag, EEVblog Mailbag, PO Box 7949, Norwest, New South Wales 2153, Australia, not Austria. So it's got to have Mailbag, otherwise I think I've ordered it. So yeah, I've already opened this and let's have a look. We have a note. Sorry, I've had this one for actually quite an embarrassing amount of time. I didn't get around to it for some ridiculous reason. Anyway, it's been opened by customs and then resealed by with DHL tape. Anyway, it comes from a US company called Standard Measurement. I'm surprised such a company didn't already exist long ago. Anyway, it's the PocketFrog. Check it out. It's a lab in your pocket. So thank you very much, Bob. G'day, Bob. He's the senior engineer at Standard Measurement. So let's check it out. Looks like it's going to be a data loggery type thing. Well, I won't do it. Oh, it's tiny. And there you go. Plugs into the USBs and it's got some 4mm banana jacks and it does sampling and whatnot. So I guess all the goodness is going to be in the software. I've got a power cord. Oh, it's even an Aussie power cord. We've got probes, power adapter, but yeah, it's basically a USB loggery measurement doodad thing. Let's check it out. It's all going to be in the software though. All right, so here's the PocketFrog, and this is actually quite neat. It's actually got a fully programmable power supply from 1 to 20 volts at 3 amps, so up to 60 watt capable power supply as well as a meter in it. So yeah, it's pretty jazzy, but it's also a jazzy price. It's $210 US. So have a look at the website in a minute. Made in the United States of America, and it must be connected to a computer USB port. Will not operate from a USB charger. Enumerates as a USB serial port. So presumably that's how it you get the comms. And here's the external power input, because of course you can't get it from the regular USB. I can't get 60 watts from that, but it comes with like this little DC barrel jack to USB-C adapter, which I would have preferred. Why not put a USB-C directly on there? I don't, mate, like I can, yeah, understand the versatility that you can use either a DC barrel jack or a USB-C, but maybe both on there. They've made this thing as small as possible. It's like a USB stick. So yeah, maybe they could have made it a little bit bigger in that regard to put the USB-C on there. I don't want this flapping around in the breeze, really. So yeah, that's the only downside physically. Anyway, you know what we say here at the EEVblog, don't turn it on. Let's take it apart and let's have a squiz. Ta-da! There we go, we're in. And yeah, I was going to say, this has to be absolutely chock-a-block. I mean, they've done a remarkable job getting everything into a USB stick, but I can't. And that's part of their marketing thing. In fact, I'll show you that. So you can see on their website here, their big marketing thing is that we pack a programmable power supply, counter timer and voltmeter in the package, not much larger than a USB memory stick. Yeah, I can understand, you know, you're putting in your little laptop bag and stuff like that, great, but you know, you could have made it a little bit bigger. There was no need to sort of, you know, it's okay. You could have doubled this size and it's really the same thing. It didn't have to be USB stick size, but hey, hat tip to trying to get it into a USB size thing. That's very impressive. So it can give you power waveforms as well. So you can simulate, you know, a battery discharge, charge, all that sort of stuff. So we'll see what frequency that goes up to. We saw that in the recent Analog Discovery 3 thing. So this is the only product that they do. Let's go to About Us. I won't try and pronounce that name in Michigan, but they're in Michigan. There you go. Hi to all my viewers in Michigan. And as I said, it's 210 Yankee bucks, which sounds a lot, but if it does the job, then it's worth every cent, of course. And they have software for a Raspberry Pi as well, and Linux and Mac. So beauty. Don't know if it's, they don't see anything about open source. So anyway. Oh no, it's 20 volts at 2 amps. I thought I read 60 watts somewhere. So I'm not sure what the deal is. A voltmeter can go up to 40 volts. You can express as power supply voltage or current as equations with your voltmeter reading as current. Nice. Run anyway. Let's install the software. This will be a very quick review. It won't be comprehensive. And done. Launch PocketFrog. Too easy. Can't move this from the other screen, but it says I have to accept these conditions. The user will not connect any of the PocketFrog banana connectors to any AC power or neutral. Yeah. I have read and understood. And the cable they supplied is one of those bi-directional, insert either direction jobbies. Nice. Anyway, we didn't finish looking at the hardware here, so we've got PCB mount banana jacks there, just soldered on. That's fine and dandy. We've got some protection diodes here and over here as well. Not sure what's missing there. There's cap, is it? C? And see, missing a couple of caps, but that's all right. And they've got a freescale jobby. I don't know what MP27 PV. Anyway, you can look that up yourself. This is not an extensive review. Reverse engineering some more protection there. There's our 5 volt. That's just serial comms. So all the power. So that's input protection. So that'd be reverse polarity protection on the input. Oh, we have to got 2 more screws. So yeah, they've done well to squeeze it in here, but I've got to like think, you know, you probably don't have to, but maybe, you know, I don't know, leave it in the comments down below if you think, oh yeah, it's the size of a USB stick. Damn, I want that. But I can appreciate the, having that as a design goal. And as no surprises for finding the other side, it's dual side populated, and they've got a bunch of stuff on the other side. We've got some big polymer caps here. You can tell they're polymer because they don't have the vents on them, the square vents there, so they're not regular wet electrolytes. And yeah, like there's not much else. Okay, genuine Molex. Oh yeah, it's got a few test points on there, and once again, you know, there's a few missing components and stuff like that, so I'm not sure if, I don't think they have an open one. I think this is the only model, so I'm not sure what's doing there, but there you go. That's a power supply and a voltmeter, basically. Anyway, that's very impressive to fit an adjustable current limit 40 volt power supply in there, 2 amps, and also the voltmeter capability, and into a USB size stick. Nice work. So there might be power curve limitations in this, but I haven't read the manual, so it might be in there. Okay, let's plug our PocketFrog in and see if it detects. Sorry, I won't show you this. Oh, something went. Windows is telling me it's setting it up. Device is ready. It's just a COM port, COM5. PocketFrog, none. Oh, there we go, COM5. Okay, there we go, we're in. I just disconnected it because I wanted to reconnect in my National Instruments virtual bench, and it's not responding. So I'm not sure what's going on here. Might have to restart it. Yeah, I'm getting a flashing green LED, so let me disconnect. Nope, still nothing. Not responding. Close the program. Oh, yeah, restart it. We're good to go again. No worries. Okay, let's turn the power supply on. Default values here, and I've got it hooked up to my National Instruments virtual bench. You can see that 1.04 volts. We've set it to 1 volt here. This National Instruments virtual bench is pretty schmick specs, so it's yeah. So that's exactly what we're getting, and yeah, you can't go below 1. Oh yeah, I can use my mousey wheel to zoom that up. No worries. Would have been nice to have presets here for like 3.3, 5 volts, you know, stuff like that. But the interesting thing is that I don't have my external power connected to this thing. So it's doing that. It's getting that power from the just from the USB connection itself. Okay, so what happens if I short that bad boy out? And we've got overcurrent. There we go. So it says overcurrent. No wuckers. Now here's where it would have been nice to tell you whether or not you're using the USB power or the external power, because the new Analog Discovery does that. It can tell you which one you're actually using, because clearly it works. I didn't expect it to work. I thought it needed the external power, so that's good. There we go. The current down there on the Analog Discovery matches that. So where is the ability to program the power supply? Is that coming? Options, enable diagnostic login, reverse scroll direction. Nope, we can do calculations, but I want to be able to like program my power supply output. Powerful automation features. Oh, I did get the USB stick, and it's supposed to have an introductory video, applications, calculation workbook. Okay, so it's got applications. Applications, what do we got? Oh, that's the actual, no, that's the actual PocketFrog software. Calculations workbook. Oh, it's just a spreadsheet with a calculation on it. Okay. Right, that might be useful for login and stuff like that. But yeah, we're not going to go into that. So that just, yeah. I assume that it tells you, that allows you to calculate, get the data specifically out, although it should spit it out in like ASCII form. So anyway, this is not a full review. I'm not going to go into that. Now, here's the thing. I don't expect this to be able to go above the 5 volts because I don't think there's a boost converter in there. So if we want 10 volts, yeah, it's going to give us 5.05 out. To do that, yeah, we need to connect the external supply. Not surprising. And again, I plugged in the external power and it's locked up. So software's still under development, I think. Oh, I stand corrected. They do actually detect external power. External power available. Beauty. There you go. They should have just said, like, yeah, message into USB power only, voltage, current limited, etc. I was trying to figure out why the voltmeter wasn't showing anything. I plugged it in. I'm outputting, you can see on the National Instruments down here, I'm outputting 4.5 volts. It's because I plugged it into the negative one and it can't measure negative voltages, unfortunately. So it's not multimeter capable. Like if I switch that over, right, if I reverse the polarity there, it just says 0. Right? So yeah, unfortunately, it will only do positive voltages. So it's not full multimeter capability, but you know, for data logging usage, you know, not for general purpose use, it'd be okay. Yeah, so we're getting 4.5 volts and we're getting 4.481. That's near enough. There we go, 22.5. Yeah, so it's working. 25 is the maximum I can go up to with the National Instruments. So that works, but yeah, like I'm not going to test the counter time or anything, but yeah, where are the automation capabilities for the power supply? Hang on, I think I figured out how to do the power supply programming. You go into calculations here, and then the output voltage, send result to output voltage, and then you can go 1 unit. I don't want a unit, I want a voltage. Is that why you have to use that spreadsheet converter? I hope not. Okay, I got it working. You just put in the formula here, 5 plus sine S running times 4 times pi. So I just copy and pasted the example that they had in the manual there. And sure enough, okay, it's running. You send the result to output. I don't know what this table here is or how to add anything to the table. I've got no idea how that works, but you can see it is actually doing its thing, and I'm sure if we hooked it up to a scope, you would see the sine wave, you know, 5 volts. So I should be able to change that to 2 volts, like that, and down here you can see that, yep, it's now changing 2 volts, so it's going above and below. So it's a 2 volt offset with a sine wave on top. So it's working, but oh, it's clunky and convoluted. I'm not a fan of that at all. I can appreciate the ability to do that. Obviously, that's great, but yeah, nah, they need to work on the interface for that. Yeah, it talks about S running, microseconds running, timers, but it is powerful. A calculation can allow you to control the output voltage from another measurement. So like the analog discovery can do, it can send its feed up its own clacker, which is really nice. But yeah, it's non-obvious and convoluted. Calculation workbook. Yeah, so that's why they provide that calculation workbook thing. Yeah, okay, so it's got all these built-in functions and operators, but like, why would you go to all this effort to build in all these functions and operators for a power supply? Like, I can appreciate the effort put in, but I'm just wondering why. I mean, granted, it looks like you can do maybe those operators on the measurement input as well, but really, I don't know. Just export. No, just leave it to Excel. Just export the data. Allow the user to log the data in, you know, text format. Right, okay, it's 1.01 volts or something, and just log it at a fast rate, as fast as you can. Allow the user to dump that, and then they can play with it later in Excel. There's no need to build this into your program, really. So, yeah. Oh, block diagram. And the LED on the front does give you error things and overload and stuff like that. Looks like it's not going to tell us anything about the power envelope. No, there's no power envelope, so you don't know how much power can dissipate when it's in, like when it's shorted and stuff like that. Oh, look, log. Select log by date. Sid knows where I am. Oh, wow. Okay. That's really right. So that's like an error. No, that's like an error log or something. Like that's a log of what it's actually doing. So that's not a like a log voltage thing. So yeah, I would have liked to have seen like, yeah, data logging, proper multimeter functionality. As I said, like it could physically be larger if I'd rather have the extra capability in there. Okay, so with the external power available, it would have been nice if that maximum there just jumped up to the maximum external power available. So let's try that. And 40 volts, nope, 20.1 volts. And that's not surprising because the plug pack is only 19 volt plug pack. So 20, maybe it's actually measuring that. But anyway, we can switch that on. And the actual voltage, 5.04. And of course, if we try and put 40 in there, it'll limit it to maximum of 20.1 volts. No surprise there at all. So that is all right. I'm not going to try the USB-C thing. So can we actually change that? So 2.1 is the maximum current it'll actually do. So let's go to max there. Well, 2.1. And let's short that out, and boom, over current. Why is the actual current showing 0? Let's try that with the National Instruments. So we'll short it out, and oh, hello. Something's gone wrong. It's not on, off. Something has gone horribly wrong. External power available. On, over current, there we go. So why it didn't show before, I don't know. It just like shut off or something. 0.76, so yeah, it's matching. So it's dropped that down. So yeah, this is not the, like if you're after the world's best little power supply, this is, it's obviously not going to do it. So it can't do the 2.1 amps. If we drop that down to 10, is that going to make a difference? No, that's not going to make a difference, is it? Yeah, it's just not, it's not going to do it. I mean, you're not going to damage it, but anyway, yeah, why it didn't do that right off the bat, I got no idea. If I short it out again, yeah, if I short it out directly like that, instead of putting it through a current shunt, it actually shows 0. Oh, and yeah, there you go. So maybe that is some sort of protection thing. I don't know, but really, I want my power supply to, like, be a constant current power supply. I want it to be able to put the 2 amps in there. So that's interesting. So it resets. So it's protecting itself, which is good. But no, if I do that, it's no good. But if I plug it into a 10 amp multimeter current shunt, which has some resistance, but the leads have resistance too, we get 0.75. So that's interesting. So that's some sort of software-y protection thing, I would imagine. But yeah, no, I want my power supply to be able to output, what I tell it to into a dead short. That's the idea. What about 1 amp? Can we do 1 amp? No, it drops down to 0.32. So, the power supply is rudimentary. Let's put it that way. It does protect itself, which is good. But yeah, it's not the best power supply by the looks of it. But of course, more characterization required. This is my first play with it, so this is not a full review. As I mentioned, it presumably will go up to 40 volts if you have a 40 volt external supply for it. But they supply only a 19 volt plug pack here, which is plenty. you know, you usually don't need to go to those higher voltages, especially in sort of like a pocket field use thing like this. If you do, more external supply, or maybe USB PD, which I'm not going to try. Because the thing with USB power delivery can, in fact, the new 3.1 can go up to 48 volts, I think it is, 24, 36 and 48 volts or something like that. But you've got to negotiate that to be able to output that. And this can't negotiate with just that little DC barrel jack adapter thing. It's unless it's actually, you can't see that, but it specifically says 19 volt power delivery. So it looks like this has a negotiation chip in it. I would presume that once you plug it in, it negotiates with power, and it's only going to give you the 19 volts. So yeah, exactly the same as the plug pack. But I think it is capable of more than 40 if you actually put 40 into it. I'm not going to test that. And it looks like the cable I've got's a little bit dodgy, so it went Windows thing when I touched it, so it doesn't automatically reconfigure. So yeah, they need to fix that in software. But there you go. That is the PocketFrog. It's still in the early stages of software development, I think, and it's at just over $200. It's pretty pricey. Like, you know, it's you can get an analog an older analog Discovery for that now. Can you? I think they lowered the price on the analog Discovery. So yeah, it's harder to compete. But this is tiny form factor. So if you want that tiny USB form factor, this could be really good. But yeah, but the power supply with a minimum of 0.6 amps current limit, and as you saw there, it's not actually capable of like doing like the set power, you know, constant current. Yeah, and you can see it's like it's in constant voltage mode there, it says. Not constant current, even though like 1 amp, like can I even set like half an amp, for example? Nope. It's, well, 0.6. No, because it's a minimum of 0.6. Yeah, so it's got limitations like that. And there's no, like, data login. I want to see data login. I want to be able to log data to an Excel file, please. Just dump out the, you know, at the fastest sample rate possible. And the power supply modulation, it does work, but those calculation things, that's all kind of as flexible as it is. Got to say it's kind of clunky, and it can only do up to 2 hertz. No, 10 hertz, I think, maximum power supply modulation thing. So it might be handy for some uses, like for slow ramping and stuff like that. Maybe, you know, set up a ramp, or I don't know how you set up a discharge curve mathematically, because that looks like how you have to do it. It'd be nice if it had options in there that simply said simulate a lithium-ion battery, for example, and, you know, stuff like that. But all that sort of stuff can come with time in the software. But yeah, it needs a bit more work. Anyway, that's the PocketFrog. I do like the little logo there. That's really cool. Anyway, I'll link it in down below. But yeah, I think that's still a work in progress. But it's interesting. They did a really good job fitting it in the USB form factor. Beauty. Next up, we've got one from Australia. In fact, Hoxton Park, just a stone's throw from here. So thank you very much, K&A Electronics. I got no idea what this is, so let's get in here. There we go. There we go. Ooh, what is this? Brown paper wrapping. It's the Omnifixo Maker's Third Hand. It's the Omnifixo. The Maker's Third Hand. I presume, I would guess, it's like one of those, like a PCB holder or something like that. Because, you know, you've got to have 3. Every engineer has 3 hands. You've got to have at least 3 hands. Sometimes you need more. Oh, no, that was a fail. I should have actually sliced that open. And what is it? What is it? It's got some, yeah, it's a clampery thing. It's falling apart. No, it's got magnets. It's magnets. Right. So it's got, yeah, magnet. Cool. Right. So it's got 4 magnety things, which sit on the metal base, which has a convenient ruler on it, but I'll show you up close. And, oh, there we go. And, wow, they're quite novel. I like ball joint with the magnetic base, plastic magnetic base bottom. I like that. And these are just, and they're clips, like that for holding your board. That is novel. I'll show you up close. wow, I haven't seen something quite like that before. Like, I've seen similar things, the PCB-ite, for example. No, it's not PC Byte, because if you wanted, you would have put the capital in there. Anyway, I've done a video on that. So Anthony from K&A Electronics, they're actually the Australian distributor for this Omnifixo OFM4 PCB holder. So thank you very much for sending this in, and check it out. If you haven't got a magnetic PCB holder like this, you should definitely get one. And this is different to the other PCB-ite ones that I've shown before. Though similar concept, you've got a metal base plate. In this case, it's relatively small, about 150 mil long. It looks like it's got a earth-in bonding point over there. That's quite handy. Inches for you Yanks up here, so that's useful. And magnetic plates. So these have got magnets on the bottom of them, but instead of just being a regular, like a crocodile clip or something like that, they've got these funky, big, large jaw opening spring clips like this. If you know what they're called, leave them in the comments down below, because I've seen similar things, but I have no idea what they're called, and they've got nice insulative things on the end. It means that you can actually put, not only just have your board edge, but you can also put them over large components like this. So this is going to be terrific. Let me try it. Oh, it's just not big enough for an Ethernet connector. Look at that. But, right? That's the kind of thing I'm talking about. Like, you can put it over existing components like that. Like, I've got it over the HDMI on this Raspberry Pi here, and we should even be able to go over this pin header. Check it out. And we're not going to damage the pin. So we can have our board and put it on an angle like that. Fantastic. Now, the only downside that I can see from this is that it doesn't need much force. Like, I'm putting my pinky on there, and it really doesn't need much force. So I'd like to see stiffer balls. Trust me, the stiffer your balls are, the better. I'd really like to see those balls stiffened up so that, so you can't solder on that, like, for example, right? And so you couldn't put enough pressure on your soldering iron, it'd just fall over like that. But of course, that's not a problem, right? If you've got it mounted vertically like that, and then you've got it in like that, right? No problems whatsoever, right? You can do your soldering and your whatnot. But if you are like having your board at an angle for some reason, like probing, for example, I've shown those flexible probes in a previous video. So yeah, and that would be enough pressure just to have, let your probe come down gently on there like that, and then pierce through any oxidization, I can say that word, with your sharp oscilloscope probe, and then, or your meter probe, and then probe your board like that at an angle. So that's really quite jazzy. So yeah, apart from the ball stiffness, which is like, it's good, but maybe a bit sniffer, might have been maybe a tad more useful perhaps, but this is incredibly useful board. You definitely, if you have not got like a magnetic holder like this, something like this, then you need one of these things, because they're so darn useful. I probably would have liked maybe another version with a larger plate. I've got the larger plate. The other one that I've got has a larger plate here if I want to do like really big boards and stuff, but this is just absolutely terrific. So yeah, maybe slightly opening jaws wider, but then that's a trade-off between the height, I guess. If they get too high, then your board gets, too high off there and you can't work on it properly or whatnot. But yeah, like, this is great. This is great. This is a winner-winner chicken dinner. You definitely need one of these magnetic holders. They're really terrific. And the build quality seems really terrific on these. So yeah, really happy with that. Well done. Highly recommended. So I'll leave K&A Electronics link down below, and this is worth every Aussie dollary-doo. Got another one from the United States of America. Thank you very much, John Nichols from ERC Incorporated, ERC Inc. So open this up. What do we get? What do we got? It's some sort of frame. No, there's no note. No note. We got a t-shirt. Thank you. Always enjoy the t-shirts. Size small or medium. I'm none of that large American rubbish. Thank you very much. But we showed up. We showed up. Somebody showed up. Yes, they did show up. Oh, I think I know what this is. I think I've had this for a while. Sorry. I think I know what this might be. Oh, I'd forgotten about this. Sorry. Yeah, I've had a few like buried in the shelf for quite some time. I think it's the right way up. Am I going to show it correctly? I think it is. I remember them emailing me this and sending this is going to be good. Look, hopefully. No, is that the white ray? There we go. It's the red team. Yes, it is. With the NASA administrator himself. It's the red team that made the SLS, that saved the SLS rocket, made it go up. Oh, fantastic. And signed, thank you very much. This is awesome. And there he is. There's the legend himself, Billy. I've done a video on Billy. And it's signed by the members of the Red Crew. Thank you very much. Oh, that's going straight to the pool room. So that's Billy, Chad, and Trent, the Red Team, or Red Crew, I think they call themselves, and with Bill Nelson, the NASA administrator, of course. And I do believe that Billy actually was there. He was the one who worked on Bill, because Bill Nelson's an astronaut, and Billy actually worked on Bill Nelson's shuttle launch back in whenever that was. So yeah, they got that leakage thing fixed, and of course Artemis 1 flew and did a perfect mission. Beauty. And we've got one from Austria, not Australia. Hi to all my Austrian viewers. Thank you very much, Peter Trumula. You know, the U with the two little dots on top. Anyway, it's a, spoiler alert, okay. Yeah, sometimes the box just spoils it. And, well, yeah, we've got lots of paraphernalia. I've got a manual. Wow, that's a pretty schmick printed manual. I don't include, by the way, if you buy one of my multimeters, one of my EEVblog multimeters, I don't include the manual. Just trying to save paper, because most people just end up tossing it out anyway. So, you know, what's the point? Anyway, this is all fancy-pantsy, and it's a, there you go, it's a USB cable tester, USB-C cable tester. So I'll show you up close. Oh, included a battery. Vada, made in Germany. Brilliant. Oh, there's another one. Is it a, no, that's a USB. That's a C to A. That's a C to A. Anyway, we'll take a close look at these up front. Always very handy USB, like cable testers and stuff like that. Very handy piece of kit. So Peter Tronmuller, there's the website, Caberqu.com. I'll link it in down below. And sent in these two USB tester boards. Incredibly handy, because especially the USB-C to USB-C cables can be very complex and actually have lots of different modes. You can see all the different LEDs here. And look at these manuals. This is actually really impressive. Check out this, like, beautiful photos in here, and then how to hook it up and the measurement and everything, and the beautiful overlays, really professionally produced. And then we have a decoding table, so we'll check that out. And oh wow, like, yep, this is the most thoroughly impressive manual I've seen in a long time, let alone for, you know, something simple with no active circuitry. It's just basically a bunch of LEDs and a battery, but you know, it's quite good. And this is USB-A to USB-C, and same thing, not going to be as complicated. Yeah, there you go, not as many modes, but anyway, let's check it out. So we've got two boards here, and I tried to put my battery into here and it wouldn't go, because look, check this out. This is actually a beautiful touch. There's actually a screw in there which holds the battery in, and it's even got its own little metal threaded insert. Isn't that a Bobby Dazzler? That is beautiful. I don't think it's actually needed though, because these usually have quite a lot of force on them. Although I guess if you want to throw this board in like your kit bag or something like that, then eventually it might vibrate out, but usually these are quite forceful. So anyway, I'm going to take that out and we'll give it a whirl. So we plug that in, and it doesn't chew any power if you're not doing anything, so it requires connection. So let me get a few test cables. And I have quite a lot of problem with USB-C cables and actually getting like an incorrect type. You know, I'm trying to connect my phone into something, and then it's like a charge-only cable and it doesn't do data, or it doesn't do USB, you know, power delivery or something like that. Really annoying. So hopefully this is going to give us a thing here. Oh, hello. That's for the shield. Oh, nice. It's actually got the shield. That is beautiful. Okay. Wow. Okay, that's terrific. So the shield is connected, and then we plug that in, and bingo. This one, it looks like, I thought this cable was really good, because it's like a real huge thick-ass cable. This is the one that came with the portable soldering iron. That portable soldering iron I reviewed recently, I think. So yeah, there's quite a few of the stuff there aren't actually connected through. So that's not good as like a high-speed data cable, because it's missing some pairs. So it's got the old school data pairs in here, and hopefully we'll should see those. Yeah, D plus and D, yeah, they've actually flipped those around. So let's actually flip this connector up the other way, and will that change? Yes, it does. There you go. So they flip around there, and if we change that, no, it stays that. But yeah, they do actually flip from side to side. But this cable, I thought it was connected all the way through, but it's obviously not. That's why it's light and flexible. So yeah, that cable is not used for a lot of stuff. So I can actually label that now exactly what it's capable of. Next cab off the rank is this real fat, inflexible one. So I'm going to assume, although I don't know, are all the connectors connected on this one? Is it a full... Yeah, it's got the shield. Let's have a look. And bingo, yep, where they're all lit up. And of course, we'll see the data. If we do that swappy swap again, we should see the data swap to the other side. Yeah, we do. But this is interesting. You'll notice that the CC2 there is not lit up as much as the other one. So hopefully you can see that. Let me change the exposure on the camera. Yeah, you can see that that's not lit up as much as the others. So it must have like a resistor in the cable. So yeah, because this is just directly going through. So this will show you by way of the LED brightness whether or not there's actually a resistor in the cable. And that should transfer over to CC1, I would think. Yes, it does. There you go. CC1's not lit up as much. There you go. So, but anyway, there you go. That cable, I can now label this as fully compliant for all the different modes. And if we have a look at the manual, and there you go, the manual tells us, if they're all lit up, then it can support all these different modes. But you're talking about your power delivery, USB 2, USB 3, right up to, 3.2 and all that sort of, whether or not debug accessory mode supported, dual lane is supported, alternate mode or audio adapter accessory mode, and, all that sort of stuff. Would have been really nice, I tell you what, if that was printed on the back here, because the back, unfortunately, it's kind of a waste of silkscreen there. Yeah, we know to plug the cable in. So if we had that handy table on the back, then that would have been really schmick. But as it stands, that is beautiful. I can now go through and test all my cables and then label them for exactly what they're capable of. And then we've got the USB-A to USB-C. It's going to have far fewer LEDs and far fewer modes because of the limitations of the USB-A. But let's try that. Look at that. No shield. No shield connected, right? So if that's, and there you go, no shield. If we flip that, we shouldn't get any difference there. Nope. And we can tell that's a USB 2 cable. There you go. So that's handy, but well, maybe I can find a USB 3. Okay, one thing I wanted to test is this cable here, which I've actually been using with my USB Scarlett interface that drives my speakers and on my main desktop. And no shield. No shield. That's probably why I've been having issues with this thing. Like, I swear, sometimes it resets and cuts out when I get up off my chair, like a static interface thing. There's no shield at all. So I think that's the reason why I've been potentially having issues with that. So I'm going to swap that for a proper... I should have known. Look at the little pissant bloody thing in this. Anyway, I'm going to tag all these. Wow, so I think that's found the problem with my Scarlett interface. No shield. And there's another short little lead there, only USB 2, not 3.1. Having a hard time finding a USB 3.1 lead here in the lab, actually. But anyway, it also shows the power source as well, which line the resistor is connected to, CC1 or CC2. I think I might have found a USB 3. I mean, look at the braiding on this and the thickness and just you can kind of tell. Anyway, will it be shielded? And will it be USB 3? Yep, we got our shield. There you go, look at that, beautiful. And you can tell that the ground is the same as the shield. There you go, and bingo, USB 3 for the win. Oh, these boards are so handy. Seriously, get yourself over to Caberqu.com and Peter Trenmuller, Will Muller, I think it's Muller, he'll send you these very useful bad boys. I don't know what the price, I can't put a price on these. They're so useful. Damn. Yeah, these are going straight into my USB cable tray after I extensively test and label all my bloody cables so I don't get caught out again. Oh, unbelievable. Anyway, that's fantastic. Thanks, Peter. Thank you very much, Daniel Cole. Cool. Not OOL, but from Finland. Hi to all my viewers in Finland. Let's check this out. No idea. It just says PCB, so could be anything. Sure enough, we have a little board. We have a note, but we don't look at the notes until we've taken a look at the thing, Bob. It's got a barcode. So, what is it? It's got a SD card, micro SD card thing on it. Okay, it looks like a battery charger, like a battery charger with an SD card. Ah, it's a flight computer. It's called the Rockit. It's designed for water rockets and model rockets. It measures altitude, acceleration, and can actuate 2 servo motors. Can be used for deploying parachutes and staging. The flight computer detects launch automatically, and different settings such as servo motor position are adjustable through the rotary switch. Yeah, there is a little rotary switch on there. I thought that was a trimmer, but no, that looks like a rotary switch. All the best from a Spanish physicist and electronics designer living in Finland. So there you go, the Rockit. We'll take a look up close. I'm not going to power it up or anything, but I'll put the pertinent info up. Let's check it out on the bench. So Daniel sent in this Rockit, and there you go. You can scan the barcode, but I will link it in down below. The Rockit Rev 1, for all you like rocket and flight, water rocket, model rockets, or whatever, aficionados. I know there's a lot of you out there, and isn't this jazzy? Nice little board. We've got a micro USB. We've got that's the lithium polymer connector. And it looks like we've got the rotary switch here to select, as I mentioned, those different flight controller modes and launch automatically and servo motor position and all that sort of jazz. And it looks like there's another little switch on there. I won't go through all the details of this bad boy, but yeah, it's got the castellated edges there, so you can hook all your external stuff up to it, and I'm sure that's going to do the business for your model rocket. So I'm not going to power it up and play with it. It's got another, is that a reset switch or something over there? But if I can get some details, I'll whack them up here. So if you're in the market for a flight computer thingamy-bob, then this thing could be a Bobby Dazzler for you. It's a nice little compact layout. I like it, and not much size, not much weight. That's a 1.6 millimeter board. Could have made it 0.8 millimeters. Shave a couple of grams off the weight there, maybe, for your model rocket. But yeah, that's really good. And it's got the position, tells you which way is up, because it's got all the accelerometers and compasses and whatnot in it. And it measures altitude as well. Yeah, and it can control 2 servo motors. So yeah, that'll do a stage thing to deploy your parachutes and your release stage, your release from the rocket, and then your nose cone comes back down or something like that. So yeah, jazzy. Anyway, thank you very much, Daniel. I'll link that in down below. Opened by the Australian Border Force. Thank you very much, David Hunt from the Old Dart in the UK, which the Old Dart is the UK, not Old Dart in the UK. The Old Dart is the UK, okay? Anyway, yeah, let's see what we have. So, yeah, they opened it because they didn't like the look. They didn't like the look of the dodgy RIFA caps. Turned up on X-ray, apparently. There it is. They didn't like the RIFA caps. And obviously turned up on the X-ray. They thought this looks dodgy. And yeah, they decided to open that puppy up. But we have RIFA. RIFA madness. Why? It's been watching my channel for over a decade. Oh, jeez. Thank you very much. As a volunteer at the National Museum of Computing at Bletchley Park. Oh man, I so want to go there. I've repaired quite a few vintage computers. Late 70s, yep, and the inevitable capacitor choice is the RIFA cap, which of course fills the room with that lovely magic RIFA smell. It's not even the magic smoke, it's the magic RIFA smell. It has a smell all of its own. I used to replace like with like. These are actually not old ones. These are brand new, because you can still apparently buy these RIFA paper capacitors. And you got these from Farnell's, and these are brand new, never been used, and they're cracked. Let's take a look at them. Unbelievable. Oh my God, why do they still make them? Oh, this is terrible, Muriel. Check it out. These have all failed. Oh, all of them. They've failed practically identically. Split right along the top. They're all split down the sides like that. Other side. Yeah, look, you can just see the cracks in there. Unbelievable. Oh, look at it. Look at it. Look, it's even split. Right down the side there, presumably where the glue attaches or something. That's just no. Come on, seriously? These were new Farnell stock. Well, presumably they were okay when they came from Farnell's, but then they stored in wherever they were stored for a while, and they've just cracked on their own. No usage whatsoever, and these don't date from like the 70s or 80s. These are like new ski. Come on. So thank you very much, Dave, for sending those in. Unbelievable. And Dave wants me to test these with the high-speed camera to see if the magic smoke escapes. Not abusing these things, just doing what they're designed to do, which is they're X-class caps. They're designed to go across the mains. So I'll put them across the 240-volt Aussie mains here and see if the magic smoke escapes. But only if this video gets enough thumbs up. Leave it down below, big thumbs up, and I will get the high-speed camera out, and I'll have to go outside. I'm not going to do it in the lab, obviously, because I don't want to stink my lab up with the not so nice smell from the RIFA caps. Oh, RIFA madness. Unbelievable. Yes, the legend is real, even in the new ones. Can't believe they kept making them after they knew that they do this with age. It's just unbelievable. These are paper caps, but whatever actual process they put into manufacturing these, they just crack. It's ridiculous. So it'd be interesting to see if they do actually blow. Can we blow them without stressing them at all? Anyway, yeah, not going to do that in a lab, because if I do actually set the fire alarm off here, it's going to cost me $1,800, by the way. Just because we've got a back-to-base alarm system which goes back straight to the firehouse, and yeah, as soon as that alarm goes off, they come a-running and then they give you the bill. Anyway, leave it in the comments.